two main levers where you can reduce your environmental footprint. One is energy consumption. Of course, energy efficiency is the solution here. And the second aspect is material intensity, and circular economy is the answer here. So easily that the materials that you put into an appliance is even more important than just energy efficiency. The whole industry in the past was looking at energy efficiency increasing. You see that on the label. It's important for consumers to make a purchase decision, but it's just one aspect of the environmental footprint. And so as soon as you look into it in a holistic way, LCAs is the method to do so.
My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models. Welcome back to our fourth and final episode in the series on recycled plastics for premium brands. In the last episode, we learned from Bosch how they organized the technical feasibility and the desirability from customers. Today, we want to talk about how to scale that to your regular product portfolio. But before we start, I have an offer for you. If you want to get the actionable one-pager about this conversation, please sign up to the Circularity FM newsletter. You can find it at www.circularity.fm. He studied electronical engineering and holds an executive MBA. He had leadership positions in product management, sales, and marketing. 11 years ago, he joined VZUG. For more than 5 years already, he serves as head of sustainability. Welcome, Marcel.
Thank you very much. Happy to be here. Thank you, Patrick.
My second guest has degrees in material science and chemical engineering. He earned a PhD in mechanical and process engineering from ETH Zurich. He worked as research and development engineer, project manager, and circular engineer. 3 years ago, he joined VZUG as sustainability expert engineering. Welcome, Marc.
Thank you, Patrick. I'm glad to be here as well.
Marc, we want to talk about home appliances. And before we do that from a professional point of view, what's the most important feature of a washing machine for you personally?
The most important feature of a washing machine is, if you look into digitalization, I really love the push message at the end of a cycle, because it tells me in the upper floor that I need to go down to the cellar to remove the clothes. That wasn't there in the past, so I had to walk down several times. So I'm very happy about digitalization in this regard.
Every IoT product manager now feels so happy about your answer. Yeah. Marc, what about you?
Being able to put 8 kilos of laundry and get it clean after 1 to 2 hours. It's pretty convenient.
Yeah, couldn't agree more with a family of 2 kids. Yeah. Let's switch to the commercial and design aspects and the circular perspective of washing machines and home appliances. Our focus here is on recycled plastics and durable products. And what is the starting point here, Marcel, when we looked to the recycled material share of a typical VZUG washing machine?
Frankly speaking, in the past, there was not such a big focus on the recycled material, especially on plastics. I mean, you get some recycled materials in other materials like metals, stuff like that, but it was never really a strategic approach in the past to have recycled material incorporated in our product. So if you open a product 3 years ago, you don't find a lot of recycled materials in it. So starting point was very initial.
Okay. And what's then the reason to change that?
It all started when we looked into life cycle analysis. I mean, 3 years ago, we have decided to measure our ecological footprint of all the appliances we have in the market. So we did structured LCAs from all of our products. And if you do that, you all of a sudden see two main levers where you can reduce your environmental footprint. One is energy consumption. Of course, energy efficiency is the solution here. And the second aspect is material intensity, and circular economy is the answer here. So easily that the materials that we put into an appliance is even more important than just energy efficiency. The whole industry in the past was looking at energy efficiency increasing. You see that on the label. It's important for consumers to make a purchase decision, but it's just one aspect of the environmental footprint. And so as soon as you look into it in a holistic way, LCAs is the method to do so. You see where your levers are, and then you come to the materials and then recycle content, and not just recycle concrete at the beginning. It's really looking at the whole life cycle, the kind of material you place into it and what happens after the end of life. That all matters very much.
What was the motivation or vision behind looking into that topic?
I mean, overall, at the end of the day, it's also the targets that we gave ourselves. For example, we have an ambitious CO2 emission target on scope 3. And purchased goods and services is an important category, so all the materials that we buy. So if you want to reduce these emissions over time, you need to touch the materials that you put into an appliance. So having 2021, we signed our long-term targets, and scope 3 was one of it. And since then, we have a structured approach and do that year by year, reduce our overall environmental footprint.
Okay. And do you have a, let's say, more holistic vision next to reduction of scope 3 when it comes to circularity?
Yes, circularity doesn't happen overnight. I mean, this is something that we all agreed on, and that's why we have defined the vision. We call that the vision closing the circle 2040. Closing the circle itself already talks about circular economy, and 2040 also indicates that this does not happen overnight, because we need to touch many things in the whole system, and that's why we have defined this long-term target, and that has a different approach than just producing appliances and selling them. It's really a holistic approach. That means looking at the whole value chain. At the end of life, what happens with the appliances today, or in the past, we were happy with just a good recycling process, but we believe it's much more in circular economy than just recycling. So we have started to take back our appliances at the end of life. We look at them at the beginning. Are they able to get a refurbishment and a second life? So that would be the ideal case. If this is not possible, we dismantle them to every single item, and then we start to close the circle as narrow as possible. We define reuse. That means we take a part out of an appliance and reusing it again. That would be the ideal case. This is not often possible. But the second layer then would be recircle, as we call it. That means to keep the resources in a loop, in a closed loop, ideally with our suppliers. So you talk with every single material, you talk with your suppliers, what's going to happen at the end of life. Recycling, of course, remains an important aspect, and repurposing is another approach where we give a new meaning to a part. Just to give you one example, is a washing machine drum can end up in a fantastic design piece in terms of a table or a pouch or something like that. This is more a funny aspect in it, but it's also one of the R strategies that we drive.
That already sounds super impressive. I feel like you touch a lot of the R strategies, and also in their hierarchy, they're meant to be worked on. Yeah. Let's zoom in on the closing the, let's say, materials loop, and focus on recycled plastics. Before we jump into the very details, Marc, maybe let's start with the end. What has been the result of your efforts of the last years, and how will this be visible in your products that you bring to the market?
So we've been working closely with the Holy Poly, the startup from Dresden, to develop an ABS compounds made out of 50 to 70% of PCR ABS. So that means with the help of Holy Poly, we built a material that is actually a white regranulate that fulfills our aesthetic specifications. So that was pretty a high target, having like a pretty white recyclate. And this is exactly what the team at Holy Poly was able to achieve: a quality that is actually unmatched on the market as of now. So we really had the chance to collaborate and make sure that something that seemed impossible became possible. This is something that today gets discarded, like the front panel, the visible parts, those extremely white plastic parts. They get shredded and they just get burnt or landfilled. And now we have a way of reusing them in the highest quality possible. That was what Marcel meant beforehand with that recycling. Being able to close the loop on the highest quality possible with our supplier, with our partners. And that was actually thanks to the collaboration with Holy Poly, an extremely good example of how circular economy could lead to lowering environmental impact.
Is this already live, or when will that roughly be live?
We already have a few thousand dryers with such front panels on the market. They've been sold already this year. And as of February of next year, we'll have incorporated in the current series of our multiple households washing machines. So, and we are looking at far more parts where we could actually do the swap between the current ABS virgin that we use and the new recyclates we've been developing with Holy Poly.
Well, there are many parts in a washing machine and a dryer, and they're made of many different materials. Why did you choose that one?
Really good question. I said it earlier. Everyone talking about PCR materials and especially PCR plastics, they say, yeah, okay, you can do that, but it will be black, gray, or with lots of points and impurities. And by starting with the most complex one to get pure, we set ourselves the challenge to achieve that goal. And by achieving that goal and showing that this is feasible for white recyclates to be on visible parts for a Swiss household appliance manufacturer, then it shows that the rest should be pretty feasible as well.
Okay. And just to be clear, it's a challenge because of the purity of the white and the visibility of that. That is the main challenge.
Exactly. Because ABS per se as thermoplastic polymer is pretty easy. Thermoplastic, you melt, you can shape it again. But being able to get actually from those appliances that are discarded in Ökihofs throughout Germany, Poland, or Republic Czech is another issue, and is being able to also separate it, like the ABS from the PP, from the black ABS from the metallic parts, being able to really have only one single type of material and of color is really where the challenge starts. And being able to have such a process that enables to have a perfectly white, yellowish PCR material that Holy Poly was able to achieve is for me just impossibility coming possible.
For people and companies out there who are listening right now and want to start it, so how did your process look like to get to that result?
We were approached by Holy Poly. They had their PCR. They already did some pre-trials, right? And they showed us the values of what they had, what like the LAB color values, the thermal, mechanical, rheological, and chemical properties as well. And we compared that to our current materials, being an ASA or an ABS. And by discussing with them, we decided that, okay, what we want to develop with you is something that not only has the aesthetical performance that we want to have for our visible parts, is also to make sure that the processability, the UV stability is actually matched to the ASA that we use actually as a basis material nowadays. And by doing really deep lab work, Holy Poly was able, through DOEs and investigation, to really optimize the composition of the compounds that we need to mix in order to reach those values and optimize actually what we want to achieve. Because, I mean, we have the PCR stream, we have two types of different virgin ABS to have an impact on the processing, but also on the mechanical properties, as well as the quantity of master batch to be optimized in order to have the best costs and results balance, so to say.
And if we start, let's say, the resource flow, the input material is coming from end-of-life home appliances across Europe, or just your products, or where is that coming from?
For the project, it actually started in Germany. So the team at Holy Poly went to different Ökihofe. I don't know how we say Ökihofe in English, but you know what I mean, I hope. And they've been discussing with like first handler of waste, so to say, and got the first batch there. But then they saw, in order also to lower the cost, because we also had an incentive on matching the virgin price, they expanded and looked also towards Poland and the Republic Czech, because they also have lots of plastic manufacturing and plastic recycling going on there. But ultimately, as Marcel said, the idea is to bring our streams of ABS material, white ABS material from our dismantling facility back towards Holy Poly, so that this is incorporated into the compounding of this free granulate.
So it's basically that you can ensure a closed loop for the products or materials you get back yourself, and then you add material through an open loop to match your volume requirement.
Exactly. Yeah. Because we are ramping up, we are building a dismantling line, but I mean, we are still talking about a few hundreds to a few thousand of machine, hopefully for next year. And compared to the few tons that we ordered and that we need for the production of our parts, then we need to have a system to bridge the gap.
An obvious question from someone who's not, or who has never been to the home appliance industry is, why the hell do we have to ensure it's like purely white? Yeah. So why don't the manufacturers say, okay, I accept certain imperfections?
Good question. Next question.
It's really a brilliant question, and we definitely want to raise that and discuss that internally as well. We from the sustainability team, so to say, we have one voice, but we are not the only one within the company, of course. And at the end of the day, you have consumers, you have consumer preferences and all these kind of things. And which company will be the first one who is brave enough to change that will open up new opportunities in using of recycled materials. And for this case, now we still remain at the white one. But of course, we would like to be, or I would like to work in the company who starts to change that. Because then as soon as you do that, you see that you even reduce even more your environmental footprint, and you can also reduce cost. So that will be definitely the next step. So I say that now, we will change that, but we invite all the other white good companies as well to do that, because at the end of the day, we all as a society need to make progress. But very good question, Patrick. We need to question many, many things. And that's one of our challenges and opportunities in our role within a company to just challenge the status quo.
And if I may add, I mean, we've been discussing that long and broad with Marcel over the years, but I mean, showing that the impossible was possible. It's always easier to remove things from a system that we developed in order to match the current system. But indeed, just by putting the things into perspective and talking to each and every stakeholder along the value chain, and also our customers and the people in product management, we have the possibility to gently show what is feasible. And going lower in the specs is always actually welcome, because as Marcel said, it lowers the price, and then it improves the sustainability, because we still have a few percent of virgin material, a few percent more master batch in order to get that white. And being able on the industrial process to keep those specifications is also pretty challenging. So we set the bar really high, and now we can lower and lower. But as Marcel said, on the point of sales, if someone sees a yellow machine and someone sees a bright white one, they'll say, "Oof, this one must be horrible." Then I take the other one. I mean, we need to change also and talk about what is actually functionality, what is actually quality, combined with sustainability.
And just to follow up on that one, based on what you said before, Marc, I just assume that if you would relax these kind of requirements, you would be able to achieve higher degrees of recycled content.
Yeah, exactly. I mean, we could go up to 95% of PCR and just putting a bit of master batch. But then what we also need to take into account is if we really want to close material loops, and especially thermoplastic loops, over many different life cycles, I would rather advocate to go for 70 to 80% of PCR and put some new virgin materials in order to keep actually the properties as constant as possible. Because otherwise, if you just like put everything in, then after a while you have really quite decrease in material properties. For polypropylenes or ABS, it's a bit different, but still, few more cycles and then it's totally goes to waste. But if you add regularly some new materials, then you can keep actually your material stock much longer.
Yeah, it's a valid perspective, because if you wouldn't do that, if you were to reach higher degrees of recycled content, and then after 2, 3, 4 times these fibers degrade, then you would need to add virgin material anyway.
Exactly. So in order to really smooth down the decay of the materials, making sure that the functionality, the properties are still good, then adding some new materials is in my opinion, a good way of keeping the value as high as possible. And at the same time, if we were to put 100% of PCR in our appliances, that means we should already have been accumulating 500 to 1,000 tons of material in order to process it for next year. And we are also building that up, but not as fast.
Yeah. Let's also look at costs, because that is usually another main concern. What have been the factors that make sure that it is a commercially viable option for you?
So at the start of the project, we had that ASA material that had pretty low material costs, and the goal of the project was to get as close as possible for the regranulates in order to match the price. We've been doing the maths, doing the process engineering, discussing a lot with Holy Poly, and at the end of the preliminary investigation, we arrived at a price that was actually about 50 cents per kilo higher for the regranulates than for the virgin material. However, and due to taxes as well and tariffs, the price of the new material, actually not the regranulate but the virgin one, increased. And now we have a delta of about 15 cents per kilo. And this is actually already, Pelze, a pretty good information, because if you keep on sourcing your materials in Europe, then you won't be impacted by tariffs. So it really helps to close material loops on the local and regional geographical locations, right? And at the same time, I mean, we haven't yet contributed with our own stream to the formulation of the holy poly material. So that means on our side, being able to lower the cost for the dismantling and the preparation of regrinds in order to put it into the material of holy poly will also have a very positive impact on costs, because our stream, as we have been seeing in the last years, is that it's even whiter than the PCR that they have been collected and gathering. So we might also be able to reduce the amount of master batch, thereby reducing the price and then increasing the PCR part. So that these are different, like, interconnected streams that could impact positively the price on the longer time, because this is what we want ultimately. It's being able to have a resilient supply chain, regional supply chain, and making sure that we can also profit from it by reusing the materials from our old appliances. And of course, the more material you produce, the more efficient you are on your processing. And we have also been talking to other different companies in order to increase the material quantity to be produced. We haven't had success yet, but many people, since the information at the Gamesse a few weeks ago, have been contacting Holy Poly, and that might also come in handy in order to increase the volume of material processed and produced.
One aspect of price is the costs. You elaborated a bit on that. The other one is then also what you can achieve on the market. Do you combine this recycled material or the share of the recycled material in the appliances with any additional communication, or does it go in there silently?
No. We think about the best way is to do good and talk about it, just as we're doing right now. As we communicated with Holy Poly as well, we are trying to proactively show that we care, and we also do things that we hope are meaningful and that make sense as well. We really want to make new appliances out of old appliances, and we tend also not to want to do just like Ecoline. We want to actually have all of our appliances that have a lower carbon footprint, because otherwise it doesn't make sense. Having something pretty fancy that no one buys that would be rather greenwashing, and we really want to make it the new standards. We have few parts where we indicate this is 100% recycled part, this is 100% recircled part, but for the white panels, we won't be doing that, because we just want to show that sustainability can also be pretty clean and straightforward.
I think in terms of communication, there is definitely something that we would like to change in the future, because if you talk about an appliance today, if you talk about sustainability, it's more or less about the energy label, and we want to change that, because it's sustainability around an appliance is much more than just the energy efficiency. And also innovation. What stands behind innovation? Is it always the next feature on a washing machine that you have, 25 different washing programs? Is this innovation? Or can you also do circular innovation or material innovations? And as soon as we implement more and more of those kind of things, we definitely want to talk about that. This is also where we involve marketing at the point of selling, how to communicate that. How is the storytelling around that? What is sustainability on a household appliance? And we definitely would like to change that towards the future, but always not first delivering and afterwards talking about it. This is a bit the approach that we have.
Mm-hmm. Following up that you already do a lot and we now focused on one specific project within recycling, and you're doing more in recycling and you're doing more in circularity. But how did the learnings from this specific project also influence other aspects of circularity?
I would say, as you just mentioned, this is what we discuss right now is one aspect, one specific example out of it. But we really would like to approach that in a holistic way. That's why we also introduced, we call that the 10 principles of circular design. Because at the end of the day, we need to make sure that the future products that we develop and design today are ready for the circular economy. That's why we have implemented these 10 principles. And there are some aspects which were since ever in our DNA, if it comes, I don't know, to increase energy efficiency and stuff like that. But if you start thinking about how do I need to design my product because I want to dismantling it at the end of life, this changes a few aspects. Or what for every single material that you put into it, you need to really argue, why do I take this kind of material and how does it really can be somehow used in the circular economy after the end of life. So this is how we would like to, in a structured way, to approach how we develop our products for the future. So this is just one nice example. And to take again the example of a washing machine, if you're dismantling it, you have 80 different parts in front of you, and you need to raise this question on every single part. And on some aspects, the answers are easy, and in some aspects, it's totally unsolved. So as soon as you have a PCB in your hand, the electronics, and you talk about circular economy, it's still a huge challenge. Metals are already done, I would say. Now we get into plastics, but there are a lot of parts involved in manufacturing a household appliance.
Mm-hmm. And like specifically this example, is it also something that, for example, influences product design?
Patrick, maybe let me give you one nice example of reuse and how that influences the product design. One of these 10 principles is, before you start a new platform, look at the old platform. What kind of materials can you reuse? And now let's take a washing machine. You have counterbalance. 2 are in there. Counterbalances last forever. I mean, they last for 100 years. So if you now develop the next platform, washing machines, you look at the old one and you see, oh, this counterbalances. Also in the new platform, I need counterbalances. But I don't change them in design because I know in the next 15 years, I always get old washing machines back and I get these counterbalance weights and I can directly reusing it in the new appliance. If you don't design that in, you can be sure that the engineers will design a new counterbalance weight in a different design, but with still the same functionality. So those kind of simple aspects, and this is already incorporated now, because you will become your own material stream. You will get your resources back from your old appliances. And it's a strategic decision to make sure that you can make the most out of it. Reuse is the ideal case, recircle is the second stage, recycling, repurposing, all these are strategies. But it's a long-term strategic way of thinking behind that, because in Europe, if you are honest, we don't have so much materials in the ground, not a lot of raw materials, but we have a lot of raw materials in our in the products around us. And it's wise to really get access to these kind of material flows.
Mm-hmm. You mentioned a couple of activities you're already doing, and it's of course also ingrained in the quality, ambition, attitude, and at the same time, every new project also needs investments. How do you get funding for all of that internally?
Very, very good question, and a simple answer. We are quite lucky, Mark and myself, we are quite lucky because we work in a company who, back in 2018, VZUG gave itself a CO2 penalty. So for all the emissions that VZUG still has on the direct emissions, Scope 1 and Scope 2, we punish ourselves on the emissions that we still have. So we put money aside every year to make projects which are ecologically wise to do, but economically maybe a bit of a challenge. typically a CEO would say, great idea, but there's no business case behind. We don't do that right now. But because we have this triple bottom line way of thinking, people, planet, and profit, and to keep the balance within these three dimensions, the CO2 fund helps us quite often in enabling projects like this. Of course, at the end of the day, it needs to be profitable as well. We are not a not-for-profit organization, and we are not a foundation. We are a private sector company. Profit is an important part, but we can, thanks to this fund, we can enable projects already at very early stages with a long-term strategic way of thinking behind that. So, for example, Marc has done a project for the past 2 years. It's called circular materials, something like that.
Circularity-able materials.
Maybe you can quickly elaborate, because that was also funded with the CO2 fund, and that's a great base now for us for the future. Maybe, Marc, you can say a few words about that project.
Definitely, yeah. So after having finished the LCAs of all our product categories in 2023, we saw that there was quite some broad material portfolio, especially when coming to plastics. And the idea was to take a step back and put into perspective what kind of material portfolio exists for each and every product category, and see, depending on the specification of the parts that are produced using those different kind of plastics, there would be any kind of overlapping specifications, and how would we be able to minimize actually the list of materials that we should ultimately be putting in our machines, right? How to reduce the amount of different materials, but still keep on the functionality and the costs in control as well. So what we did with the money from the CO2 funds is to screen each and every part in our machines, put together a summary list of the plastics we would like to investigate and see what their properties change would be between the virgin state and after 15 years in our appliances. We did that for 12 plastics because, as Marcel said, metals are pretty good, and we also at VZUG have decades of experience working on metal sheets, and we know that the lower your variation in material, the easier you can handle your complexity. For the plastics, it's a different story, and with those 12 different materials, we've been working with the Fachhochschule in Nordwest Schweiz with the Professor Markus Grob and the Fachhochschule Ost in Rapperswil with the Professor Schwendemann, in order to investigate the properties, so thermal, mechanical, rheological, processability properties of those two states, and then decided also to develop some kind of simulation database so that we can understand what are actually the decrease in material properties between a lifetime of like 0 years in a machine and after 15 years. And the results are pretty interesting because if you look at the polypropylenes, that's the most of the plastics we use in our appliances, there is really few differences between the 15 years. It's a different story for the polyamides. We are working on that as well, especially flame retardant materials. But for the polypropylenes, which are in really huge quantities used in our appliances, then we see that using PCR up to 70 to 80% would be actually a no-brainer. And it gave us the Zahlen, Daten, Fakten that the engineering world so likes in order to build up ecosystems with our material suppliers and make sure that from the dismantling, we can get those streams back. So that's thanks to the CO2 funds. Otherwise, we wouldn't have been able to actually have like a clear basis in order to improve and minimize while keeping the functionality.
So it's basically a bit of having the fund for fundamental research and then of course also applied projects that are not directly profitable yet, but pay into your vision and follow the hypothesis what you think how material prices in the market will change. Yeah.
Exactly, definitely, and making sure that we understand what we do and we understand the technical value of the materials inside our appliances, because as of now it's out of your eyes, out of your heart. You just shred it and then you buy the next one. But if you have the possibility to really show that you don't have so much loss in properties and the specifications are still good, then you can save quite a lot of materials.
This funding mechanism sounds a bit like a circular competitive advantage. Do you already have a feeling that pays off, or the specific project pays off? So how do you evaluate that?
Typically, if the CO2 fund invests into projects like this, we need to show up front already that we also always bring that also into discussion. That, for example, we just made a project with Outokumpu circular green steel. We invested into this 10 times less CO2 intensity on green steel, and from the beginning on, we said we love to be early adapters, and we know it costs a bit more at the beginning, but you need to have first customers, otherwise you can't really scale it up. So we can be early adapters in this kind of projects, but always with the transparency that in year 2 or 3, we need to get the price down towards a competitive dimension with the comparable product. So it's always enabling things where we believe that it will pay off in the future. Sometimes it's true, sometimes not. For example, decarbonization of our own truck fleet. The first trucks that we bought were 3 times more expensive than a diesel truck. But now, 40 years later, we are almost at the same level. But we are now already since 40 years on the way. So it gives us a competitive advantage because we can start things earlier thanks to that, but not just blind. It always needs to shows us that it will be the right investment for the future.
Wonderful. And in doing so, you also give a signal to the market. You pave the way. You show that things are possible where others thought they're not possible. And you don't only do that, you also talk about it. Thanks, Marc and Marcel.
You're welcome. Thank you very much for having us.
Thank you, Patrick. Thank you very much.
This marked the last episode in our series on recycled plastics for premium brands. Thanks to Holy Poly for sponsoring this series. You can find the actionable one-pagers about all these 4 conversations by signing up to our newsletter. Find the newsletter at www.circularity.fm. Let's drive a profitable circular economy. And please don't forget, the most abundant renewable resource is your imagination. My name is Patrick Hübscher, and this is Circularity FM, the podcast about understanding, building, and managing circular business models.